This is lesson 103, VHDL example 70. And in this example we'll look at block RAM and block ROM. Remember in the last lesson we looked at distributed RAM bits. There's also a separate memory blocks in the FPGA. These are separate from the CLBs, called block RAM. And for example, in the Nexus 2 board, the 500 part, there are 360K bits of such block RAM. This is over 46,000 bytes. So there's much more memory that you can use in block RAM than you can in distributed RAM. You generate these block RAM modules the same way you did the distributed RAM ones with the core generator. The only difference is you'll select single port block memory here. If you double click on that, you'll bring up this single port block memory and give it a component name. We'll call it BROM 8x16. We're going to make 8 words, each 16 bits wide. Notice that the depth here can range from 0 to over 260,000. Now notice that these block ROMs or block RAMs are registered outputs. That is, there's an address and D-out's the output, but there's also a clock input, which means that this D-out doesn't show up until the next rising edge of the clock. So unlike the distributed ROM and the ROM that we made in our VHDL program, where you put in an address and out comes the output, that is a combinational block, this is actually a registered output, so it has a clock. Now we will also make a COE file for this one. You'd click on the load file to load that CEO, and then once you do that you'd click on this generate to generate it. Here's the COE file we'll use for this example. We'll have 8 values, 16-bit values, 0000, then 1111, 2222, and so forth up to 7777. So these are 4-digit hex values. Here's the simulation, and you see that if we put in the address as a counter going from 0 to 7, the output data goes 11222 and so forth. But look at the address. The address changes on the falling edge of the clock I've shown here, but notice that the data doesn't show up until the next rising edge of the clock. So at address 1, the contents of that memory location is 1111, but it doesn't show up until the next rising edge of the clock. Then the address changes to 2. On the next rising edge of the clock, the 2222 shows up. So this is an important feature to remember when using this block RAM and block ROM. We can write a little top-level design that you can test it with on the board. We will have these entities, the usual entity. We'll make a clock pulse. So what we'll do is we'll have it so that when you push button 0, you'll increment a counter for the address, and then you can display the output on the 7-segment display. That's what this program will do. So we'll just port map our clock div. The clock pulse, when you press button 0, you'll get a clock pulse coming out. The clock pulse will be the input clock to a 3-bit counter, since we have 8 of these 16-bit values. So the counter will generate this address, so this address will then be connected to our BROM 8x16 component. This is the one generated by the core generator, and you would get this port map template from that VCO file. So the name is address, a clock, and D out. So the clock goes to the clock pulse here. D out goes to X. X is then will display it on the 7-segment display. So if you download this program into your FPGA board, then every time you push button 0, you can cycle through the contents of the ROM and display the values on the 7-segment displays.